Hi, and welcome to Henry's Drawing Studio. We are on our series of solving the past questions, and today we want to look at Wassce 2018, question 5, which asks that we find the center of gravity of a given diagram using the funicular method. I welcome you to this class, and let us view into it and start sampling. That considering the scale that has been given to us as 1 millimeter is to 4 millimeter, then we'll have to consider the size that has been given. So we have a size that is 60 millimeter, and what we have to do is, if we have 60 millimeter, then what we have to do is 60 divided by 4, and that is going to give us what? 60 divided by 4 is going to give us 15 mm. Then we have another side, 300 mm. So it will be 300 divided by 4, and that is going to give us 300 divided by 4 will give us 75 mm. And then we have 400 again, 400 mm, which will be equal to 400 divided by 4, and that is going to give us 100. And the last one again, which is 60 mm, so it is going to be 60 divided by 4, and that is going to give us 60 divided by 4. So we have 60 divided by 4, and 60 divided by 4 is 60 divided by 4, and that is going to give us 15. Let's draw our object. So then we have the base converting from 400 is now 100 mm. So we measure 100 mm, and that will give us this height, this length. So we can label this maybe A, and then what? B. Then with the help of our set square, we draw to get the height. Now we have the upper part of the L to be 60 mm, which will be 15 now. So we measure 15. And then 15, this side too is 15. So quickly we draw our 15 up. And then we have our 15 to at this side, and that gives us the object itself. So we can do away with the other parts that are not needed, right? Okay, so this is 300, up is 300, and 300 after our conversion we had 75, so we have to measure 75, and then we transfer it there. Make sure you always use your divider in taking and transferring the measurement. So we have this. Then we close up the object at the top here. Now we'll continue to label the side. So we have A, B, and then here will give us C. Here will give us D. Here will be E, and here will be F. Good. So the next thing that we have to do is that we are going to use the forces or auxiliary method to get the centroid. And so we have to get this into at least three different areas. And so we can take this area. So we can join this, just as this over here. We join D to this side to give us another point. So we can call this one F, and then we call this one A, B, C, D, E, F. So we can get here to be G. So now we are having three areas, and these three areas are this side, which we can call Q. We have this, which we can call R, and then we have this, which we can call S. So after obtaining this, then we'll have to use the diagonal method, that is finding centroid using the diagonals. So we use the diagonals to find the centroid of this part Q, R, and S. So let's do that. Then again, we find the centroid of R. Then we find the centroid of S. So X will be from this side. So now we can say that this is the center of gravity for the area Q. Then that of R is also here, and that of S is also here. Now that we've been able to find the centroid or the center of gravity for these areas, then the next thing that we have to do is to find the area of such objects. So we come to this side and find the area. So let's take it accordingly. We have Q. So area Q will be equal to, then we look at the kind of object that you have over there, and this is a rectangle. So rectangle is going to give us the length and then times the breadth. Now from the onset, we realize that this whole area is 300. And so 300, when we take the 60 from this side, this will be level 4, and this will be level 240. And so we have length, or we have the area to be length times what? Breadth. And the length here is 240 mm, then multiply by 60 mm. Right? So with our calculator, let us get that done. So 240 multiplied by 60, and that is going to give us 14,400. So we have this to be equal to 14,400 mm square. Then we come to the area R. So area R will be equal to, that is also giving us a square. So a square will give us L times what? L. And that will be equal to 60 by 60. And this is going to give us what? With the help of our calculator, we have 60 multiplied by 60 and that is giving us 3,600. So we have 3,600 millimeter square. Then we'll go to the next area, which is area S. So area S is going to give us, that is also a rectangle. So we are talking about this area. We are talking about this area, right? So area S is going to give us length times breadth. So if that is the case, then let's come back to the diagram again and look at what we have over there. So when we talk of area X, we have the whole distance from A to B here to be 400. So 400, and then we have this to be 60. So when we take the 60 out of the 400, we'll be left with 340. So 340 mm. Then we multiply the 340 mm by the height here, which is also 60 as given in the diagram. So we have 60 mm, right? Then we move on and check the calculating for that. So with the help of our calculator, we can also work on this now. We have 340 multiplied by 60, and that is going to give us 20,400. So we have 20,400 mm square, and that gives us the areas of this. But from our question, you realize that we were given another scale, and that scale says that the scale says that 1 mm is equal to 400 mm square. 1 mm is equal to 400 mm square. So we are going to consider that 1 mm is equal to, so using the scale 1 mm, let's say this is the scale. So the scale given to us is what? 1 mm is equal to 400 mm, right? Square. Good. So if that is the case, then we are going to use the areas that we found. We'll consider them under this scale. So we have area Q, and that is equal to 14,400 millimeter square. So if we are comparing it to the scale that we have over here, what is going to happen is that we are going to, this will imply that we will divide the 14,400 by 400, and with the help of our calculator, let's do that. So 14,400 divided by 400, and that is giving us 36. So now we have 36 mm. That is the first part of it. Then we go to our area R. So area R, which is equal to 3,000, area R, which is giving us 3,600, right? It's 3,600. So 3,600, we'll have to convert it. So now we have 3,600 divided by 400, and that will give us what? With the help of our calculator, let's check that. So we have 3,600 divided by 400, and that is giving us 9. So this is going to give us 9 mm. That is for the area R. So we move to find the area of S, and then as find, we have area S to be equal to 20,400, right? Mm square. And considering our scale, which is 1 mm is equal to 400 mm square, then we can say that here we have 20,400 mm square divided by 400, right? 400. So this will do away with this, and then the mm will do away with this. And then when we come here, let us help use our calculator to solve this. So 2400 divided by 400, and that is giving us 51. So this is going to give us 51. This is going to give us 51. So we'll keep the mm, but all these ones are giving us what we found now are giving us the load line. So that will give us how our load line is going to be. Now with that, then the next thing that we have to do is that we have to look for lines from the object. So we are back to the main object once again, and we are going to look out for lines. And because of how this particular diagram is, if we should project our lines that we're going to work with on our load lines from the center, if we use horizontal lines, we are going to have two lines passing at the same point. And so it is very good that you use angular lines to do that. And to get an angular line, you can use any of your set squares. So I'm using 45 degrees set square, so that I'll get my lines at 45 degrees from the center of what? The object. So let me get this first. So I would like to project these ones up. So from this side, I'll pick here, and then I'll project at an angle of 45, right? Then the center of this one too, I'll project at an angle of 45, right? And then from this side S, I'll project again at an angle of what? 45. So this gives me my load lines. The same way, I'll have to project these load lines in another angle that will be perpendicular to the first angles that I've worked with. So let us look at this. Now I have this from here. I can now project this. So from the center of R, I have it projected this way at an angle of 45. Then from the center of the next center that I will be able to get is Q. So center Q projected this way, and then center S, I also project them this way. So I have these as my load lines, and they are going to help me to find the centroid of the object that is given to me. Okay, so from this side, this is what we're going to do. We are going to consider this. So let me draw a line here to indicate where. So we have this as forces that are what? Acting from the center or the center of gravity of this point. So we have this acting in this direction. This is also acting. This is also acting in this direction. Now, what's the magnitude of these forces? So we go back to our calculations that we've done already, and then where we've converted them from the mm squared to the Newton. So we have here the first one, which is Q, has a magnitude of what? 36. So this is 36. Then R has a magnitude of what? 9. So we have a magnitude here of 9. And the last one, which is X over here, X has a magnitude of 51. So we have 51 over here. Now, when we come to this side too, we are going to do the same thing. Let's arrange it in that same manner. So let me say we have this, and these are going in this direction, right? So in this particular manner, then this is how we're going to go. So let's take the first one. The first one that we have over here is the R. and then R is what? R is 9. So here we have 9 here. Then followed by Q. Q is 36. So we have 36 here. And then we have the next one, which is what? X. X is 51. So here we have 51, right? Then we're going to use this to prepare our load line. And the load lines must act in the direction of the forces that are acting. And so let's go to the side up here. And then what? We get our load line over here. And on this load line, we're going to do our measurement. So let's get here at the top here. I'm going to get my load line. So from here, I get a line that represents my load line, right? And on the load line, we are going to measure the forces that are acting. And so the first one, and then it must be in accordance. So we have from this side, this, that, and that. But before that, we'll have to know what we call the Bose notation. Bose notation gives us what? A way of numbering. And so as I have my, how do we call it? As I have my space diagram here, then I have to label this. Maybe from A, I have here B, I have here C, and here will be D, right? And so my measurement will be taken from A. So I'll take A to B, B to C, C to D, right? And so from here, I can get a point on this line, label that point A, and it must be in what? A lowercase letter. Then, what's the magnitude of A? It's 51. So let me get my 51. And then what? I'll measure that on the load line. So I have 51, right? So from A to B is what? 51. I have my 51 here. All right. So this becomes my B. Then from B to C is 9. So I'll have to measure my 9, and then I'll mark it on that. So this is 9. Then that will give me my B to C, right? Okay, so this becomes my C. Then I'll go to the next one, which is C to D, and that is 36. So I'll take the measurement of 36 from my rule, transfer it, and then I have it here. And that sends me to where we call D. So from A to B is 51, B to C is 9, C to D is giving me 36. So that is it. Now, after getting all this, then the next thing I have to do is to locate my pole on the other side of the load line. So this way. So let me locate my pole. Please, the distance from your pole to the load line is determined by you. So you can choose any distance. And then the exact location is what you like. So let's take it, I have it here. I've taken this point to be my pole. So I'll name my pole O. Then I have to draw straight lines from my pole to all my points on the load line. So I have from O to A, right? O to A is giving me this. Then I'll go to O to B. So O to B gives me this. Then O to C, that also gives me this. And then O to D will give me this. So I have O to D, right? Okay. Now that I have gotten this, then there is a need for me to draw what we call the link mechanism or link diagram. or link polygon. It is not link mechanism, it is link diagram or link polygon. And this will be drawn using these lines that I have over here. That is what? My lines on the polar diagram. This diagram is called polar diagram, right? So we can say this is the what? Polar diagram, right? So I'll be using this to draw my polar diagram. And these ones, when you pick them, you pick lines that are parallel to this to bridge their gaps, right? So when I look at this, we have A behind here, we have B here, we have C, and then D also is behind, right? So it will not be appropriate for us to start from, how do we call it? To start from A and D, but rather it will be good for us to start from B and C, because that will give us the chance to bridge the gap between B and C. So let us start from B. So I'll pick my B. I want a line that is parallel to B, right? So this is a line that is parallel to B. And then with the help of my set square and then what? Another straight edge, I will draw that line. And that bridges the gap between the space B. So I have this between B, right? Then I'll have to take C, and C must also be taken in its own direction, a line that is parallel to CO, right? So this one, I'll call it BO. Then I have to take my CO. So this is my CO. So I'm taking my CO comfortably. Now when I take my CO, the CO should intersect with what? BO at a point on the line there. So we have this. Then I have this as my what? CO. So CO will also come to this. I have my CO, right? So I can call this line CO. Now, when I get my CO, now from the point of intersection here and then here, I can draw my A from this side downwards. And then from this side, I'll have to draw my DO. And so let me pick my AO. And AO is this, right? This is my AO. Do you agree? Okay, so I have my AO. Now I have to slide it till it comes in line with what? The point over here. So let me pick it again. Let me pick my AO again. And I'm picking this point, right? So let me bring it down a little. Then send it up again. And that gives me my AO. So this line will be my AO, right? Now you can extend it to infinity, right? But this can be kept for the meantime. Now let us also pick our DO, and this is DO. So I'm picking DO from this side, right? So I have to slide it in such a way that it will intersect with what? My D here. So I have to draw this. And then you realize that this is my DO and this is my AO. They intersect at a point, right? So where they intersect, let's name that point X. So we'll be drawing a line that is parallel to the loops that are acting in the direction of, or parallel to the loops that are acting from X. to the object, right? To the object. So this is what I'm doing now. So slide it till it gets to this side and get this line, right? So this line from this it means the centroid will be on this particular line, but we don't know where exactly it will be. And so unless we find it here as well. And so what we have to do again here is also to get another load line and draw our poly to draw another load line here and get a polar polygon over here. So let's draw a load line. This is our load line. And as I said, the load line must always be in the direction of what? The forces that are acting, right? So our first force that is acting is 9. So let us also take this area. We can say that what? This, we can say Q, R, S, or since we have used Q, R, S already, well, Q, R, S, and then here is T. So from here, we can say that Q to R. So our first point will be point Q. And just as I said, it must be in what? Small letters or lowercase, right? So let us move on. And I'll take the measurement of this. This is 9. So we'll pick the 9 here. From here to this on our rule, we pick 9 and then we measure. So these are 9. These are 9. So here we can say that this is what? This is R. Then from R we go to R to X, and that is 36. So we pick 36 from our rule, 36, right? And this is my 36. So from R 36, I'll get this point, right? So this will be my S. Then we'll move along again. We'll have the next one, which is what? S to T, and that is giving us 51. So I have to measure 51. Right, this is 51, 51. So from here we have 51, and so that will give us the location of what? T. Then again we'll have to locate what we call the pole behind the load line. So we can locate our pole somewhere here. Then when I locate our pole, I call my pole O. So I have O. Then I have to join from Q to O, right? Q to O. Then R to O. Then I'll also join from X to O. So SO is also there. Then finally from T to O. So I have T here and then O here. So I have TO. And this gives me again my polar diagram. Right. Now that I've obtained my polar diagram, just as we did in the first one, there is a need for us to do what? To pick these lines and then make sure they bridge the gaps that they are related to. So Q must bridge a space within Q, R must bridge the space between R, and then S must also bridge that space for S, and then T must bridge a space for T. But since Q and T are at the extreme edge, it will be best for us to take the Q, R, and then what? S. So I'm going to take this accordingly. So I'm picking my R first. I'm picking my R first. Then from that side, I'll have to slide and then what? Take or draw a line to bridge R. So I'm picking it from this side, and that bridges what? R. Then I'll pick that of S as well. So this is S. Then I'll bridge the space for S. That is continuing from where R has ended on the bundle between R and S. So I have to take this, and then it goes here. Oh, I have to take this. So let me pick my S again, right? So I'm picking my S, and I have to slide it till I get to the point of R here. So I'll draw this line to bridge the space of S. So I have my S over there. Now I have to pick the next one. I have my Q and then what? My T. So let me pick my T first, and T will be from the end of R, right? So I have this. So you can support it from any edge at all. So I'm taking it from this side. From this side, you slide it till it gets to where the R or the X is, right? So we'll draw a line from this side. It has no specific length. Then I'll pick my last one, which is what? The Q. So Q is also here, and Q must also bridge the space of Q, right? So let's pick the Q once again. And this is my Q, a line that is parallel to Q. So from here, I'll slide it till it intersects with Q at the side of R, right? So I have this. I realize that this being my R, O, and this being my S, O, and this being my T, T, O, and this is my Q, O. So they have a point of intersection. That is from my T, O, and then Q, I have a point of intersection. And just as we did for the other one, we have to pick a line that is what? Parallel to the load lines that are acting. So let's take it from the load line. A line that is parallel to the load lines. And then we bring it to the space of what? We bring it to the space of the intersection. So we can also give the intersection the name, right? So let's bring it there first and then give it the name. So we are bringing it to the intersection of Q and then what? R. Q and T. So let's name that intersection maybe Y. So we draw this line from Y, and I'll like you to represent it using what? Short dashes. So you realize that this line, as you draw, it will also intersect with the X that you've drawn from the other side, and where they intersect, that particular point here become the center of gravity. So at the end, this was the point that we were looking for throughout our search over here. Thank you very much.